welcome to the Power Hungry Podcast. I'm Robert Bryce. I'm the host of this podcast. We talk about energy, power, innovation, and politics. And this week is Indian Point Blackout Week. I'm having guests on to talk about the closure of Indian Point in Buchanan, New York, and why it should have not closed if we're serious about climate change, grid reliability, pricing, et cetera. And I'm pleased to welcome Reiner Kuhr on the podcast. Reiner, welcome to the Power Hungry Podcast.
Oh, thanks for having me, Robert.
Did I pronounce your last name Kuhr? Is that the correct pronunciation?
Her is a little better.
Kuhr. Okay, thank you. So, Reiner, I'm going to ask you to introduce yourself in just a minute, but I'm going to give you the quick preface that you spent your entire career in the electric power sector, and now you're an adjunct professor at the University of Massachusetts Lowell. But my tradition on this podcast is to have every guest introduce themselves. So now I've given just a little bit of your background on who you are, but if you don't mind, imagine you've arrived at a party, you don't know anyone, and you're introducing yourself. Please, by all means, introduce yourself.
Sure. I guess I'm an energy technology economist now, based on 3 years of teaching graduate students at University of Massachusetts. But my career has actually paralleled the evolution of the power industry. I started in the 1970s as a chemical engineer when there was a surge in nuclear projects and coal projects with Stone and Webster. And I spent probably that decade working on site selection for nuclear projects, looking at the environmental licensing and economics of alternatives, and worked a lot with integrated resource planning with some of the regulated utilities that were evaluating nuclear projects. Then in the 1980s, we saw a lot more of a shift away from nuclear to advanced technology and clean coal. There was an oil embargo. A lot of projects were shaping up that took me away from nuclear into clean coal, solar. I did a lot of early work on solar power with solar repowering of a gas plant and regional studies looking at making lots of electricity from solar. In the 1990s, we got into privatization. So we saw a surge in gas plants being built, a lot of project development, and I got involved with the New England Power Pool in developing reference design and economics to support integrated planning in New England.
So this has been, sorry to interrupt, but I interrupt a lot. I hope you don't mind.
Sure.
So this has been your entire career, looking at the economics and the deployment of electric power plants. So if you don't mind, is that fair? Is that a fair assessment?
Sure.
Okay. Well, so I want to cut to the chase here because I'm really focused on Indian Point and the closure of Indian Point, because I think that this, in my view, should be seen as an inflection point and one regarding the seriousness of climate politics in America. So let's look at you emailed me last month, and I realized, oh, well, I want to talk to you because you've done a study on economics and which forms of generation are the best bargain in terms of reducing CO2 emissions. So I'll tee this up because you told me this in our previous discussion and on email. Why was the closure of Indian Point a bad move from a purely economic standpoint?
Well, a lot of my work is focused on carbon abatement costs. So a carbon abatement cost is a calculation that says, well, how much more are you paying to eliminate a ton of carbon? And if there was no value to reducing carbon, we wouldn't have any solar or wind in New England and a lot of the country. But because of policy putting value on carbon reduction, there's a lot of subsidies in place. So what happens with Indian Point is, by continuing to operate Indian Point, you would spend more money than buying that power from gas plants and other generation in New York. But if you value carbon emissions and you look at other ways to reduce carbon emissions, you can model a number of technologies. And if you model rooftop solar, you end up spending about $800 a ton to avoid a ton of carbon dioxide emissions. If you do large wind farms, photovoltaic installations, even offshore wind, you're looking at $200 or $300 a ton to avoid carbon emissions. And if you extend the life of an existing nuclear unit like Indian Point, it only costs you about $20 to $25 a ton to avoid carbon emissions. And that's because the size of the subsidy that would be required to cover the difference between operating and fuel costs uh, at Indian Point, relative to buying that power from cheaper gas-fired units, that difference is relatively small compared to the huge investments that are going into renewable.
So this is a particular interest to me because I have rooftop solar panels on I have rooftop solar on my house, about 8.5 kilowatts. And so you're saying that keeping Indian Point open would have cost a 40th. We're serious about reducing CO2 emissions. Effectively, as a country, we're paying, I'm using the royal we here, 40 times more to take a ton of, or to avoid a ton of carbon emissions from the electric power sector than we would if we had simply kept Indian Point open. Is that a fair summary of what you're saying here?
Yeah, I mean, that's one of the reasons I'm promoting carbon abatement costs as a method to evaluate policy. If you think about how cost effective these investments are, if you put a rooftop solar plant in New England, um, and you put that same plant in New Mexico, you get twice as much energy out of the same facility by putting it in New Mexico. So the carbon abatement cost of promoting rooftop solar in New England is, could be twice as high as, or New York could be twice as high as building the same plant in the Southwest. So if you fragmentize the policy, you have states trying to subsidize carbon, decarbonization. You get into situations where these investments are very inefficient.
Well,
And not,
and I'm sorry to interrupt, but I mean, shouldn't that be one of the key drivers here? I mean, and you pointed out when we spoke on the phone the other day that in fact New York has a law requiring regulators in New York State to estimate the cost of various abatement technologies, and apparently they did not do any of this and closed Indian Point anyway. Is that your assessment of what happened?
well, I think there's a number of factors that, what I heard from various interested parties. Indian Point is very close to New York City. So there were some concerns about, the closeness to large population centers and evacuation routes in terms of, those kinds of possibilities. But, New York is supposed to be implementing social cost of carbon in its planning. So social cost of carbon becomes an important metric. So what is the social cost of carbon?
I'm sorry, that social cost of carbon is what economists have come up with to say we're emitting this much CO2 and it's going to have a cost to society as a whole of this number. Is that a fair? I don't know what the technical definition is. Is that a fair summary of what that cost of carbon is?
Yeah, there's several reports out that try to calculate, the present value of all of the economic losses that will occur as a result of the negative effects of climate change. And the range of estimates has been, I think, 10 or $15 a ton recently under the Trump administration, using a lot of the same analysis. So when, under Biden, they've revised that number up to 50 by changing the economic assumptions. Your present value, the impacts at a lower discount rate, and you get a bigger number. So
Sure.
It's kind of a silly argument. They're arguing about what discount rate to use to come up with the social cost of carbon. But it's an important metric because if you're going to set policy to spend more money to reduce carbon emissions, you should have some measure of what happens if you don't do anything. So to me, the social cost of carbon.
Right, and then from a pure dollars and cents standpoint, if you're buying something, you're not going to spend more than you have to abate or to achieve a certain outcome. So in theory, then anything over $50 a ton would be misallocated capital. It would be malinvestment. Am I jumping too far ahead here?
No, I think you're right on. I mean, if the state of New York set its climate policy based on a social cost of carbon of $50, and it went back and looked at the the social cost of carbon is two things. One thing is it's the cost of not doing anything, right? So if we don't put in any solar or wind, what's it going to cost us? The other thing is it represents you have to consider the effectiveness of an investment, right? So if New York State spends $20 billion to reduce carbon emissions, but the rest of the country and the rest of the world doesn't do anything, is that investment effective? So the social cost of carbon could be zero if the rest of the world doesn't cooperate with you, because it's a global problem, right?
Right.
So if a small part of the world spends a lot of money to reduce carbon, and it's saying, well, I'm rationalizing it based on $50 as the cost of doing nothing. The rest of the world has to be in a consistent policy track for your investment to be effective. The other way to look at social cost of carbon is the equivalent carbon tax that would be needed, right? So if we imposed a carbon tax of $25 a ton, then Indian Point revenues would go up and probably be enough to keep them operating. So my calculation of $20, $25 a ton of abatement cost equates to an equivalent carbon tax.
So,
So
and I think this is key here, and this is really why I wanted to have you talk on the podcast. And a reminder, my guest is Reiner Kuhr he's an adjunct professor at the University of Massachusetts Lowell. You can find him on LinkedIn. We were talking before we started recording, Reiner, that you don't really have a call to action. You're not selling a book. You're retired. I'm assuming you've made your money. You're not after anything here. You're not trying to sell anything, but you're trying to bring some rationality to discussions about carbon abatement. And I think this is one of the other reasons why I'm frankly just so outraged by the closure of Indian Point in terms, yes, grid reliability, electricity prices, but what you're saying is that this is from a purely economic standpoint. This was a bad decision. If the state of New York is as serious as they say they are on reducing CO2 emissions. But I want you to you talked about how you calculate you did your calculations based on regional characteristics. You've looked at these different technologies not just in a model, but you have a model that you want other people to look at and use, but you've looked at it regionally because the cost of these different technologies are going to vary by region. Is that a fair assessment of your work?
right, I mean, certain technologies are much more effective in other regions of the country, and gas is still the primary flexible fuel. And you've talked a lot in your other podcasts about reliability and resilience. And in running these models and understanding how the power grid works, you have to look at how you squeeze carbon emissions out of the grid, and you do it by reducing how much you run gas combined cycle plants. And gas combined cycle plants are the primary source of flexibility in the power grid. Nuclear plants don't provide much flexibility. They want to run when they can, and wind and solar don't provide any flexibility. So the problem is that when you add up all of the inflexible generation and your loads start getting lower than the total of your inflexible generation, and this has happened a lot in California, you have to curtail a lot of the output. You have more.
And in California, you're talking about curtailing solar in particular, right?
Right. And they wanted to curtail nuclear. They wanted Diablo Canyon to go back and figure out how to ramp down to make room for the solar stuff. So having so one thing I've really learned a lot, and when you start teaching, you find out how much you don't know, and you end up learning a lot more than the students. So developing these models, to me, flexibility is more important than reliability. Nuclear is sold as a base load technology. Well, there's not much room for base load technology when you're loads during part of the day go negative. Your loads go negative when you got too much wind, right? If you look 10 years ahead and you've got lots of offshore wind and lots of onshore wind and lots of photovoltaic, the more inflexible generation you add to the grid, the more wasteful it becomes. You end up having to having periods where if you have a competitive power grid, people that are getting subsidies to run are going to pay to run. And you know, working with ISO New England to understand how to model the grid, you know, we're looking 10 or 15 years ahead with negative pricing in the grid. You know, you've got wind farm operators that get tax credits. You've got renewable energy credits being paid to those plants that operate. This is very disruptive to the grid. And, you know, nuclear will suffer because it'll see a bigger and bigger drop in revenue to make room
if I
for.
can interrupt, Reiner, because I want you to repeat that because you said it in a way that I haven't heard it before. But you said the more inflexible generation you add, the more electricity you're going to waste. Did I hear you
Yeah.
correctly? How did you put that?
Well, you know, when you model it, you have to model the grid hour by hour, which has been an elusive thing, and I've come up with a very simple way to do that can be used to support research. But when you model hour by hour, you know, you see the loads coming up in the morning as people go to work. You see the sun come up, and then loads go back down when there's a lot of solar output. A lot of solar happens behind the grid. You know, rooftop solar is called behind the meter generation. So um, when you look at the hours between the morning and the evening, there's some rapid changes, and you can only address those changes of thousands of megawatts in a few hours by ramping gas plants up and down. And if you try to get rid of the gas plants to get rid of carbon, you know, you want to run them less and less. What are you replacing them with? You're replacing them with more inflexible generation. So I think what we need is, in the future, if you look at developing new technologies, we need ways to add flexibility to the system. You know, adding new baseload nuclear isn't going to help because there's going to be so many hours a day when there's a lot of wind and solar. So we need flexibility in the loads. We need to maybe thermal storage, you know, heat pumps with thermal storage, turn off the heat pumps during peak periods, store the energy, or advanced nuclear SMRs, you know, develop SMRs that run 24/7 and make hot salt, and then build a power plant with off the hot salt tank that follow the loads. You can do peaking, you can do intermediate load. Steam plants run off of molten salt storage system, just like the solar reserve projects in Arizona. You have a solar receiver that runs during the day. They heat up salt, and then they try to run a base load plant off of that stored salt, which is interesting that a solar plant is designed to run as a base load plant, where they would do much better having a flexible plant design.
Sure.
So there's a
I want to come back to this idea about inflexible generation, but I want to make sure that we keep Indian Point in focus here because I'm dedicating several episodes to this closure of Indian Point. And why? Because I went there in 2018. It's in my film, our new documentary, the film I made with Tyson Culver, Juice. It's in my book, A Question of Power. I visited there in May of 2018 and was really amazed by the technology and how much output was coming from 1 square kilometer. So let me put this question to you because I know your specialty is on economics, and I want to come back to that. But let me ask you about Indian Point specifically. Why did Indian Point close?
All right. I mean, that's a good story. I visited Indian Point when Entergy bought it. I led the independent review for the banks to finance the purchase price of Indian Point, and
what year was that, sir?
that was back in early in the 2000s, I think.
Right, yeah, I think
And
it was about
you know, when
2000.
Entergy got a great deal on Indian Point, and I think they had to throw in Pilgrim as collateral for the financing, and it was several $100 million when they bought it, and that was when privatization broke up the the power industry in New England and the Northeast. And privatizing a power plant has a lot of impact on its economics. And if we want to talk a little bit about private ownership versus regulated utility ownership, regulated utilities do their planning on a long-term basis. They have a 30-year integrated resource plan. It's all approved by regulators. They're allowed to make a fair rate of return as long as they do what they've agreed to with the regulators. And they were generous as owners. You put a lot of people at the plant. You had a lot of budget for safety and training and improvements, and life extension was evaluated based on a low cost of capital. I mean, regulated utility can raise capital at a lot lower rate than a private owner.
Right.
If regulated rate of return might be 6 to 8%. So if you invest in new equipment at a nuclear plant, it's costing you 6 or 8% to raise that money. If you're a private owner and you got to make a major replacement or improvement at a nuclear plant, it might cost you twice as much, to raise equity.
Because the capital cost is higher.
Right. So the cost of capital for a private owner might be 10 or 12%. It might be 6 to 8% for a regulated owner. So some of the big utilities that have a regulated set of plants and an unregulated set of plants have a very different financing philosophy for the two plants. I've given some papers on that. It's,
Sure. But I just want to steer you back. So you're making
so Indian Point.
You're making a broader point about what really is a state-regulated entity versus a deregulated entity. But why did Indian Point close?
Right. So when this transition happened, and they no longer were in the rate base, they had to justify every dollar that they put into the plant. As a new owner, they also saw declining revenue. Now they had to compete in the wholesale power market at a time when gas prices were going down, and gas development, fracking was going nuts right around that time, 2000, 2010, that range.
Right.
A lot of gas appeared on the market, and people were building combined cycle plants, and these combined cycle plants were producing power at below 3 cents, below $30 a megawatt hour.
Right.
And Indian Point and a lot of other single unit plants, if you look at their fixed operating costs, just as a snapshot, the fixed operating costs might be $25, $26 a megawatt. The variable operating costs maybe $1 and fuel 5. So you need 34, 35 dollars a megawatt hour, on the average each year to cover those costs. And
that's a break-even number. That's not a profitable. That's not counting a return.
Right. And you might need to put some more capital in there from time to time if you've got
Sure.
major upgrades or replacements. So the market only produces $25 to $30 a megawatt hour typically, right? So it gives you some numbers to visualize. So you have this small shortfall. And if I was the owner of Indian Point, I'd start cutting budgets. Maybe they had 1,000 people working there. Now I got 500 or 600 people working there, but I'm sharing staff with other plants because now I'm a fleet owner. I'm not just
Right.
an owner of a couple of plants. But there's some economies that come out of privatization. People become more efficient. They optimize and justify every expenditure, but you start to cut corners, and a lot of discretionary costs start to fall by the wayside. And I'm not speaking for the owner. I'm just talking in general, right? So you can get into trouble with the regulator because now they come and inspect your plant, and you've had a year where you haven't made much money, and you've had to cut back a little bit on staff or training, or you got a bunch of red tags popping up on the plant because you haven't been aggressively maintaining it that year. It kind of creates a slippery slope. And that happened to Pilgrim. I mean, Pilgrim got into a lot of trouble when it was inspected and the NRC inspectors sent an email and somebody got their hands on the email and it said, oh, you're falling behind in training,
And this
you've
was
got
the Pilgrim. This
deficiencies.
was the Pilgrim nuclear plant in Massachusetts, right?
Right, which kind of went through the same thing as Indian Point a few years ago. So,
And it was also owned by Entergy as well.
right, so
So
Entergy's struggling with a plant that doesn't quite make enough money to cover the traditional budgets. So it has to either put money into it or sacrifice some of the expenditures. And you can only do that for so long. And I
so
think
your
that's kind
argument,
of what,
your point is that you think Indian Point closed because of economics. Where I mean, from what I've seen, that the economics for the owner, right? That they weren't getting they weren't getting the subsidies that wind and solar were getting, right? I'm cutting ahead here. They weren't getting the investment tax credit, the production tax credit that are given to solar and wind, respectively. But what about the political part of this? Because this was, Cuomo, the Entergy was also fighting a lot of litigation over the plant as well, right? So I understand your point about the economics, but there's a big political part of this, no?
yeah, I mean, I guess the relationship between Indian Point and the state government have always been poor. And because it's so close to the city, there was a large, there's a large safety issue raised by the people who didn't like nuclear, and that filtered its way into state policy. So I think the state government in New York has always given Indian Point a hard time, and it hasn't received support where other plants like Fitzpatrick that are further away from the city have been getting a lot of public support. So I think its location was part of the problem. But I think
And
it's
those and those
fundamentally
and those
economics.
and those upstate plants, Fitzpatrick and Guinea, and I've forgotten the other one. They were given zero emission credits, right? They were given taxpayer money to continue operating in upstate New York, where demand for electricity is low, but they wouldn't extend those same, we'll call them out of market payments, subsidies to Indian Point because of the alleged concerns about safety at Indian Point. That's my understanding. Is that what you see as well?
Yeah, I think that's the case. I think so. There's more policy issues at work than just economics from the state level. They didn't like having Indian Point so close to the city in an area that the population has built up dramatically. And then, if people start complaining about evacuation routes and um, safety concerns, it created more of a policy dilemma. But, from an economic standpoint, um, if New York put a lot of value on decarbonization and compared the economics, I don't think Indian Point, they might have tried harder based on the economics to address whatever safety concerns were there.
So let me restate that, and if you don't mind, restate it then. So you're saying if the state of New York, had really looked hard, put a sharp pencil on the issue of carbon abatement and Indian Point, they would have kept it open,
I,
or they should
I
have kept
believe
it
so
open.
from an economic standpoint. Yeah.
So if you don't mind, so if can you say that definitively from an economic standpoint?
Oh, absolutely, absolutely. They're spending a huge amount of money on solar and wind, and for a very much smaller cost of carbon. Again, it's $20 a ton of carbon versus $200 or $300 for large wind and solar facilities, and $800 for rooftop solar. So they're spending, like you said, 40 times as much for a lot of the decarbonization options that they could have avoided. So if you calculate out those numbers, that's a lot of money every year for New York ratepayers.
So it's just a bad. If you're looking at it from a pure dollars and cents standpoint, we can talk about other issues, but from a pure dollars and cents standpoint, it's a bad decision.
Yeah, I agreed. Same with Pilgrim. Pilgrim would have saved New England, maybe $100 million if they kept it running.
So what about the reliability, Reiner? Because you're an expert in this issue on grids, and I've thought a lot since I've written my book, since I started doing the podcast about grid reliability, resilience. I was blacked out here in Austin in February during Winter Storm Uri, and I didn't like it. And there's a lot of talk about it increasing resilience, reliability in the grid. How important was Indian Point to grid reliability for the city of New York?
Well, I think the New York power grid has a lot of gas-fired capacity, and I think the reliability is defined by your ability to meet the highest load during the year. So you have to install enough capacity and consider contingency. So if Indian Point was down out of service, you rely on gas turbines. So gas turbines provide reliability. You need more gas turbines and have higher contingencies without Indian Point being there. So obviously taking Indian Point out of service will put more pressure on having gas-fired capacity. And reliability is measured by capacity, but a lot of the carbon emissions are measured in energy. And so I think taking Indian Point out of service has a much bigger impact on the energy supply than it does on reliability, because reliability, you've got older plants, you've got peaking plants that can be built for $500 or $600 a kilowatt. You can build a gas peaker and never run it. So reliability is something that's addressed all the time. You can also buy and sell power to other regions. New York exchanges a lot of power with New England.
Sure.
And there's a lot of power coming in from Canada now. So, reliability is a more complex issue. To me, flexibility is the key. Taking Indian Point out of service puts more pressure on combined cycle plants that now have to run all the time to make up the base load, and maybe reduces the flexibility of the grid. So indirectly, reliability is an issue, but as you go forward into the future and you build lots and lots of inflexible solar and wind, Indian Point was also an inflexible source. So ultimately, it would have suffered economically with the state's policy to double or triple the amount of solar and wind going into the grid.
So it's an interesting point that you're making, and one that I haven't heard before, this idea that these baseload plants like nuclear plants are inflexible in that you can't switch them on, switch them off easily. So you're saying flexible generation is gas-fired power plants, that's the
right.
But others would argue, well, batteries would make the inflexible wind and solar flexible. But you made a good point in your brief on this. You said using batteries to extend the amount of usable inflexible generation is very expensive and would more than double the carbon abatement costs for wind and solar. So you've said my rooftop system here, and here in Austin, it's amazing to see the number of vendors who are talking about, oh, get a Tesla power. Remember the blackout? Get some Tesla power walls and put rooftop solar on your house. Well, you're talking tens of thousands of dollars. But anyway, if you don't mind, explain to me, why would batteries then more than double the abatement costs of wind and solar? So instead of $800, I'd be at $1,600 per ton. I'm just jumping ahead here, but why are batteries so expensive in that solar and wind scenario that you're mentioning there?
Well, battery costs have come down a lot, and they're probably below half of the cost of a battery plant. A lot of the battery plant isn't going to get cheaper if batteries get cheaper. So if you start to project that battery plants will drop in price, I don't think they're going to drop a lot more than they have. And you have to pay for it. You have to borrow money or finance the battery, and you have to pay back that capital cost. And there's some operating costs. And if you work that out with current estimates of large battery systems, it costs you about $30 a megawatt hour to move energy from one time to another. And that's, I'm sorry, $300 a megawatt hour. So the cost, no, I'm sorry, it works out to $300 a ton of carbon.
Okay.
So if you're if you're
And you're
reducing
saying,
carbon,
and you're saying to move, if I, a sunny day in Austin and I want to store a bunch of electricity, you're saying it's, and I want to deploy that electricity in a week or a month. You're saying that just that storing of that quantity of energy is going to cost me roughly $300 per ton of carbon avoided. And that's,
right, right.
and that's on
So you,
top of the maybe $800 a ton that I'm already spending on the rooftop solar to start with. You're saying we were at
well,
$1,100 a ton?
if you're looking at wind farms and solar farms, they save carbon at about $200 to $300 a ton. So to put in battery systems that move that energy from daytime to evenings, if you look at how many hours the batteries operate and how much money they have to make during those hours, they're going to have to charge um, a lot of money that doubles the cost of that power.
So
And
but what you're saying here is that, I mean, there's a big project that's going in Oklahoma. Doesn't that they're using wind and solar and batteries, and they're claiming this is going to be cheaper. Well, so that I'm not playing devil's advocate. I'm not seeking an argument here, but what I keep hearing is, oh, wind, solar, batteries, this is going to be the cheapest option. So who's wrong here? Are they getting it wrong, or is there something you've missed here? How does this explain what's going on?
well, you have to break down their numbers, and a lot of the numbers get hidden in subsidies, right? So if you have to look at the unsubsidized cost of the project. What's the unsubsidized capital cost with and without batteries? And how much does that extra investment in batteries extend how much of the energy can be used to avoid curtailments? And if you look at it that way without subsidies, you'll see that there's a direct investment that has to be paid for through so many megawatt hours each year, and you can work it out pretty easily. And by bundling storage with a solar or a wind plant, actually makes the economics worse for the battery, because any investment, if you have to recover the cost of the investment for each unit of energy that you process, if you only use it half as much, it doubles how much you have to charge, right? So if you're only running the battery on sunny days in an area where it's sunny half the time, you end up spending a lot more just using the battery um, during sunny days. In California, it's sunny most of the time, and you're really looking at a daily cycle. You can charge the batteries once or twice a day um, if you can make money through arbitrage. Arbitrage means you buy power when it's cheap and sell it when it's expensive. And there's not enough arbitrage in the range of wholesale prices, especially in New England that we've looked at. There's not enough variation there to pay for batteries. And the only time you can make it look better is if you start to have negative pricing. You build too much wind and solar, they drive the price, they pay to run. And then you can, if you own a battery, you can make more money by getting paid to take the power and then making money during peak periods. And even that is pretty limited when you start modeling it by the hour. So you have to look at hourly modeling. You have to break out the costs functionally of a battery, what it does in a day's cycle. How much does it cost to run? How much does it have to charge to move energy? So, but to me, batteries don't even show up as a decent option, because if you apply the social cost of carbon, even if it's $50 or higher, and batteries are adding $300 a ton to move energy around, it just doesn't make any sense from an economic standpoint. So that's the Achilles heel of a lot of these state climate plans. They think they can overbuild solar and wind, a lot of offshore wind in the Northeast, and then when you have way too much inflexible power, they're going to invest in a lot of batteries to move some of that inflexible power back into the market. And the economics look terrible when you do that. And
Well, so I'm sorry to interrupt, but what you're saying here is so counter to, frankly, and I've listened to a lot of this, so counter to the popular narrative, Reiner. I mean, you're marching to the tune of your own drummer here, which I applaud. But where are the other people getting this so wrong then? Because I mean, I hear this over and over from utilities. Is it because the subsidies are skewing the economics in their favor for the wind, the solar, and the batteries? How are they making it work?
Well, there's if you look at energy, it doesn't make much sense. There's a market for ancillary services and other sources of revenue that can pay back the cost of batteries. But there was a big EPRI report on sources of revenue for batteries, and it's simple. It's pretty simple to model if you use public costs for batteries and you dispatch them. And I am finishing up a report that will have a section on how those numbers work. It's pretty straightforward. There's not. I don't think I'm doing anything radical here. I'm just putting the numbers into a format that makes them easier to understand. I haven't seen that kind of an economic. I think Lazard publishes economics on battery systems, and you have to look closely at their assumptions and how much utilization is there on the batteries, what's the capital cost that has to be paid off. When you start levelizing costs, there's a lot of economic assumptions that flow into that.
Sure.
What's the cost of capital, what and you can always pick a set of economic assumptions that make something look better.
Sure.
Um,
So let me shift gears here a little bit because I want to keep the focus on this on Indian Point and also Indian Point versus renewables. But let me zoom out for just a second. We've heard the Biden administration. I've written about this in Forbes. I've written about it elsewhere. Biden administration is claiming that they can completely decarbonize the U.S. electric grid by 2035. In your view, is that possible?
I think it would be very difficult. I mean, you'd have to be building huge amounts of battery storage systems at a huge cost, you know, billions, tens of billions, and I'm not sure the market supports development of battery systems that quickly. So I'd like to see the details of their plan. When I've run models looking at the Massachusetts and New England targets, how fast you can move, how much capacity you can add to the grid. You're doubling the amount of inflexible, to cut carbon emissions in half. You're doubling the amount of inflexible capacity that operates in the grid, and you're starting to spill a large amount of energy. So as you invest more and more in wind and solar, each subsequent plant is worth less and less because you can't use all of that energy. There's more and more hours of the year that you're wasting energy. So the carbon abatement cost goes up. If you start curtailing 10 or 20% of the energy, or a lot more from later projects, your carbon abatement cost goes up from $200 or $300 a ton of carbon to $300 or $400, and it gets more and more expensive the more inflexible generation you force into the grid, and you're trying to retire gas plants that provide the flexibility. So there's a inherent conflict between getting rid of carbon in the grid that's being provided by your only source of flexible generation. It's intuitive. It's intuitive, but nobody seems to recognize that, and that's the reason I'm really promoting these models to universities so that they can go back and work with the state agencies and check these numbers and do a sanity check on what's going to happen to the grid. If you talk to the grid operators, they're agnostic to economics. ISO New England isn't allowed to comment on policy. They don't run economic studies. They're forced to operate a fair wholesale market. And there's a big controversy over whether somebody can bid negative into the market. And that destroys the revenue to a lot of the flexible generation, right? If you own a combined cycle gas plant, and now you have to, a lot of your revenue goes down because the prices collapse. I did a study for EPRI before I retired.
If I can just pursue
Sure.
that one point, because you make it in one of the points you sent to me earlier, that negative prices reduces the value of inflexible generation assets. some flexible generation will be needed to balance the grid during surpluses. So you made a point there just a moment ago where you're talking about the more inflexible generation you add, solar and wind, the less valuable it becomes.
Right. And
I've
any
seen that many
inflexible,
times.
right, any inflexible generation, including nuclear plants, become less valuable when you can't use as much of the energy that they produce. So nuclear plants may
So
be,
you're reducing capacity factor across the board. Then you're utilizing them less. Therefore, the capital cost goes up. Is that where what is that the essence of where you're going with this?
well, you have to, the grid operator is going to tell a lot of wind farms that they can't run during certain hours when your loads are low. They're not going to tell nuclear plants to shut down. The existing nukes are going to continue to run as must-run units. That's the current philosophy in the grid. But the revenue that a nuclear plant gets will go down. If the nuclear plant has to match market pricing and there's negative market pricing for 5% of the time, what's going to happen to the annual revenue for Seabrook or Millstone in New England if they have to pay to run a lot of the time? So it's going to put even more pressure on the economics of existing nuclear plants, which provide the cheapest carbon displacement. So there's these massive contradictions that start to appear when you look forward 10 or 15 years. So if you say the Biden administration is going to, try to get to net zero by 2035 or something, there's a lot of stuff they haven't looked at, including how deregulated markets work. How and the study I did for EPRI looked at the what's the residual value of a solar or wind plant after the tax subsidies expire, right? A lot of regulated utilities were interested in, well, let's let a private developer build a wind farm. They'll collect the tax benefits and then we'll buy it cheap afterwards. So we were looking at, what would happen 10 years into the life of a wind farm or a large photovoltaic facility. And you start looking at the value of these plants when there's a lot of overbuild. People are building new wind farms with lots of subsidies. People are building new solar farms with lots of subsidies. And the subsidies are good for 10 years, and these things are going to pay to run if they're competing with an old plant. And the old plants aren't going to be able to run. They're not going to make much money. Most of their revenue will be hurt because whenever they operate, there's too much capacity on the system because of all of the other solar, and there's not enough money to make repairs, replacements. If you try to sell it, the market value of an older solar plant will be very low, right? Nobody will pay a lot to buy a plant that isn't going to make much money. So what's going to happen in 20 years? We're building out huge amounts of solar and wind into the power grid that's going to be self-destructive from a competitive revenue standpoint. And these facilities won't be maintained well. They'll be, they're lucky to be able to do any replacement or repowering. And all of a sudden, we're going to lose a lot of that capacity out of our grid. And then what do we have to do? Put in a whole new set of subsidies to rebuild them in 20 years. So a lot of the solar and wind that was built in 2010, will be what, 25 years old by 2035? How much of that solar and wind capacity will still be running? And how much of it will have to be replaced with a new set of subsidies, right?
So if I can interrupt here, Reiner, because what you're getting to here, and it's something I've thought about, is that this idea of electricity and the grid and the centrality of it to our lives has somehow been obscured by a lot of these different rent-seeking entities, right? That say, oh, if I just get a little subsidy, then I'm going to help decarbonize. We're going to save the world, save the climate, save the whales. Being a little facetious here, but there's a seemingly not seemingly there is a lack of understanding about the importance of the grid and its reliability, resilience, and instead this deregulated market has allowed it to be kind of balkanized. And what you're talking about here, what I hear you not say is that we're headed for a train wreck on
Yeah.
a lot of different fronts here. So does what I'm saying about the grid and its importance and kind of the ignorance by policymakers of what's happening, does that ring true to you?
Yeah, I was going to use the term train wreck. I hadn't been on in a podcast before, but I've had these little podcasts in my mind between 4 and 6 a.m. in the mornings, visualizing this train wreck in the power industry where you're trying to replace um, flexible generation with inflexible generation at a scale that will be totally destructive. And the analysis of the practicality of that, as well as the economics of that, are poorly informed right now. So that's what gives me my motivation to pursue this in retirement as an educator, and to set up some tools that make it more obvious, to add some clarity to this. And I think it's a big problem, and the politics work against it right now, right? The politics, the lobbying, the fear and urgency seems to be dominating a lot of the policy, right? If you start to question, I spent 20 years of my life doing due diligence, independent reviews. You know how hard it is to raise money to build a plant, to get people to pay more, to build a certain kind of plant. So we're spending hundreds of billions of dollars based on policy that is not subject to the same standards as private investment, right? If we were to do due diligence, if we were to apply some governance and go back and do an independent review of these climate plans, and really go back and challenge as an investor would, maybe on behalf of consumers. Who's the investor here? The consumer, ultimately. How much can we rely on this concept of a tipping point? How good are the models that are being used to set the basis for this policy, that we need to get to net zero by a certain date? Are we going to spend tens of billions or hundreds of billions of dollars to try to get there if there's substantial uncertainty in the driving force behind that? Is the IPCC a lobbying organization? Should we be challenging state climate plans that rely on the best science available, which is based on IPCC reports? And if somebody were to try to do a real due diligence and a formal independent review of the basis for these investments, I think that's an important omission right now. You need governance, you need coordination, you need independent reviews before you spend that kind of money. And right now there's no mechanism for that. And that's been a big part of my life. So that, it really bothers me to see, billions, tens of billions, hundreds of billions of dollars being invested without careful scrutiny of the effectiveness of those investments. If the rest of the world does nothing, are we going to spend $1 trillion to reduce carbon emissions from the US while China and Indonesia and India continue to expand their economies and their emissions? So there's a big picture due diligence governance gap here. We're being carried away by policies that are driven by fear and urgency without careful scrutiny in terms of practicality and economics.
I think that's a great summary of what we've been talking about. So, but that's in getting it back to Indian Point. The way I interpret what you just said is what we've seen is a massive government failure. A government failure to understand the importance of that resource and the economic value of those two gigawatts of generation of reliable capacity. Am I overstating it?
Yeah, I mean, from an economic standpoint, if I was a consumer in New York, I'd go back and challenge that. Maybe. But I don't think the consumer advocacy is there because there's such an anti-nuclear sentiment may be embedded in the policy itself. So, maybe the economics were trumped by the some nuclear safety issues that weren't properly communicated or resolved. I mean, you could spend a lot of money to address safety issues to the extent that would be effective and maybe resolve that. I don't think there was ever an effort to do that. I don't think there was a will by the state government to overcome those kinds of concerns. And the public, I don't think the public had access to that debate, right?
So let me just ask you, so in your view, should Indian Point have closed, or should have, from a economic reliability standpoint, should have been kept open?
I think it should have been kept open. I think if you still had a regulated grid with the 30-year integrated resource planning that was looking at economics that's constantly challenged by the consumer, you would have looked at Indian Point as a long-term asset that could have found ways to continue to operate with a great benefit to the ratepayers. But that regulated system and process of integrated resource planning is no longer there to provide that mechanism.
Well, it's deeply unfortunate. And I'm glad to get that summary from you, because I'm going to be talking about Indian Point for a long time, and the closure of Indian Point for a long time, because I think it provides a real lesson in how government is failing the consumer here in terms of on a lot of different ways.
Yeah, we've got a lot of other nuclear plants that are threatened for closure, and there should be a bigger focus on getting the policy people to understand better the economics of that, and not let more nuclear plants close prematurely.
Amen to that. Well, Reiner, that's a great addition to what we've been talking about. And if you don't mind, I think we're going to draw to a close. Ladies and gentlemen, my guest, I've been pleased to talk with Reiner Kuhr. He's a adjunct professor at the University of Massachusetts Lowell, more than 40 years in the power sector. You can find him on LinkedIn and read about his background. And Reiner, when you issue your report on this, will you be posting it on LinkedIn so people can find it there?
Yes, yeah, I'll use LinkedIn as a place to post it. I also submitted comments to the Massachusetts State Climate Plan, and I'll post those as well, which get into the same issues.
Good, right, yeah, because what you sent me was a great summary of what you had submitted to the state there on that. So, well, great, Reiner. Many thanks for your time. It's been a pleasure talking to you and getting your views on these things. We're going to have more on Indian Point Blackout Week. So tune in again for the next episode of Power Hungry Podcast. I'm Robert Bryce. We'll see you next time. Thanks again, Reiner.
Thanks, Robert.